Solve triangles, still with variables in there. So in terms of, so the question here was long story about what it is, etc. And one of the words next to the sketch was that WXYZ is a trapezium. So then you must know that there are parallel lines. And if you didn't know that, you wouldn't have been able to carry on, because that's crucial to know. If this is alpha, then that will also be alpha, which you don't have to write here, but you're going to get marks for knowing it on your sketch and using it in your sum then further on. Then man said to you, whatever they're asking you, first go get all the angles you possibly can use, even though you don't use them all. So then this would be 180 minus, and there's a reason why we write it that way, because we know we're aiming towards sin of that, or cos of that, and then it'll be a proof path sum, or a proof sum in this case. In other words, reduction formulas. So for that, it would be alpha plus beta, and it's true. Add them together and subtract it from 180, then the proof sum would be able to go. And then for this one, it's theta and alpha, so this would be 180 minus. And now it doesn't matter whether you said alpha plus theta or theta plus alpha. Question was, find the sign, xy, in terms of alpha, beta, theta, x, whatever all the stuff is there, in terms of. So if that's the case, I have to go to this triangle that has at least one side. This bottom triangle's got no sides, and this is the one that I want the side in. So I'll have to go to the triangle that does have a side, so that means in triangle, whichever way you chose to write it, WYZ, ZWY, doesn't matter. I'm going to use the sin rule, and we're thankful if it's the sin rule, especially in these cases, because it's a little bit smaller. Can I use the sin rule? Yes, because I've got pairs. There's the pair I have. Then I can work out ZY, but why would you want to do that? Okay? I'm going to work out WY because that's the connecting side or the common side. Once I've got it there, I can use it in this bottom triangle. So I'm going to use the sin rule. So I state the sin rule for my first mark. Then I'm going to apply it because I'm trying to find WY, and I put it at the top. It's just good practice to always put your unknown value at the top. So it'll be XY over the sin of. Then the side that I have is x over the sin of. Okay, so you're seeing the reduction formula here. So that's going to become just sin of alpha plus beta. Do you see the reason why we do it this way? Make sure you know what you're aiming for, make sure that you're in line. And then on this side we've got WY over sin B. So can I not, in that same step, put it to the other side by doing what? Timing it so it's at the top. And there's your value for WY. How many marks? Most probably about 4. It would be for the sin rule and for the substitution, and definitely for this angle you worked out. Because you did a little bit of work. And also for this reduction formula. To get to that actual reduction formula, that would be worth more because there's maths that I've got to give you marks for. Then we go into triangle. To find the actual sum that we're looking for, namely xy. So I can put xy at the top over its partner sin. That one again. With all the brackets, make sure you've got enough brackets there. Alright? Do I not need to write the sin rule again? No. Once you've done it once, you don't have to do it again. There's the rule. Apply. Now I'm just applying it. And if you want to write it all the time, it's fine. Then the side that I have, I don't have any side. No, you do. We just didn't write it here. Once we have WY, I'll just say I've got it. I'm not going to attempt to write it. There's too little space. So that would mean I'm going to take the WY and put it on top of sin theta, right? Then we need to still substitute that. with that value over there. Let's do that first. On this side, we can simplify already a little bit because there's a reduction formula. Poof, sin theta plus alpha. And the sign, plus or minus, is positive because I'm in the second quadrant and sin in the second quadrant is positive. I didn't mention it there. It was also goes poof, but it's sin, so it's positive because I'm in the second quadrant. If that had been cos, second quadrant, negative. Right, so that's a little bit of a reduction. Then we're going to go for xw, that says, wy, x sin beta over sin alpha plus beta. So that whole piece is what I'm indicating over there. And when you do this in a test, use a highlighter pen. Highlight the wy, highlight this thing, everybody can see. It's good practice to do this. And then what happens to this sin theta that's underneath the line?
You times it by
Times by?
1
Also just good practice. It's not necessary to do it that way. You could have written them all three on top of each other, but later on you're going to have to do this principle of if three things are on top of each other, you've got to do multiplication of the inverse at some space. Earlier, later, doesn't matter. There's one step left to get to xy, and that is multiply by sin. So that sin theta plus alpha must be somewhere at the top. And I'd rather want it to be one big fraction because that's more simplified than having two fractions. Not really, but okay. So what do I have left at the top? X sin beta, and that sin theta plus alpha, and at the bottom I'm just writing them next to each other. Sin and the bracket, and sin theta. Now, if the sum had said, prove that xy equals, then I know I'm right. But unfortunately they didn't, so I didn't know if I was right. If the sum had said, prove that, at the bottom there was sin theta in front of the sin bracket, write it the way that they want it, so that they don't miss that yours is actually correct. But there's nothing more to do here. And again, how many marks? Definitely for the sin rule again, for the reduction formula, for this whole thingamajiggy that you've multiplied with the inverse, and then for your total answer. It wouldn't be an answer mark if they gave you the answer. But this answer would be worth a mark because they didn't give you the answer. So we're around about 8 marks for this sum. Okay, that's fine. And it's actually quite difficult. Right? Okay, again with writing in terms of variables, this question said, could I have asked you for the area?
Yes.
And then would I have been able to do the area here? What do you need for area? Because we haven't done area in a little bit.
2 sides and an angle.
Do I have 2 sides included angle?
Yes.
Well, actually you do, if you just know that it's isosceles, so this also has to be. So you do have 2 sides and include angle, so you could have been asked. But do you do area when you're able to do it?
Yes.
No, only when you are asked to do it. So this question says, prove that AB equals. So you're looking for a side. The moment that you realize, but now remember, we've been doing sides and angles now for a week or so. So you're into it. But if you're inside of the examination and here comes a Pythagoras and cos sum, and here comes reduction formulas, and here's a Kerr sum, trig equations, and all of a sudden this pops in, you've got to realize, what are they doing? Oh, they're asking for sides. What do I do if it's sides and angles? I've got tools. All sorts of tools, including Pythagoras, including grade 10 trigonometry with opposite over hypotenuse being cos if it's a right angle triangle. But if it's not right angle, we've got sin and cos. You know, we are going to ask him sin and cos because that's the new work. Are you with me?
Yes.
See it in bigger picture. I'm looking for sides, so I need the sin and cos rule. Can I use the sin rule in this one?
No. Yes.
You could. How? Where's the piece? You have an isosceles triangle, that's why these angles will be the same. This angle would be 180 minus y divided by 2.
Yeah.
Meaning that this would be 90 minus a half a y, both of them. Which is perfectly correct mathematically. But what does the question say? Prove that AB looks like this. when you do the sin rule, it's not going to get to that. What gives it away actually? Except for the cos, also the square root. Square root's telling me you should be working with the cos rule, and that's what actually has been given. Two sides will be included. Angle. You're able to work with symmetry. You're not going to get to what they're asking you. So you've got to learn from the question. You've got to read what should be your process. So if I want that AB, and I'm going to use the cos rule, it's A squared equals C squared, so C squared minus 2AB.
2BC.
Thank you, I'm so glad you're awake because I'm not currently. Right, BC
Cos.
and cos. Copy necessary. Okay, I'm now right. The side that I'm looking for is AB. So this should be AB squared, which I'm going to put in the square root just now. The B square and the C square are both the sides that include that angle at y, so it'll be x and x, and 2 times x and x, and in between those two is the angle y applied. So then to get AB just on its own, this would be a big square root. Okay, so I'm getting somewhere. Simplification. That's going to be 2x squared. This is going to be minus 2x squared cos y. And the main mistake that kids could have made here is to say that that's 0. Because it's not. Because it's multiplication. So you've got to multiply before you subtract. And then if you do that, it's the order of operations that are wrong. The only thing you can do here is what? Common factor, namely? Well, it is 2x squared. And then what's left?
1 minus cos y.
Which makes me happy because I'm aiming for that thing. But something's got to happen still. You're going to take out the x squared. Remember, the whole rule is if it's all multiplications inside, whatever, you can take them out one by one and say square root of that square, square root of that square, square root of that square. Are you with me?
Yes.
But if there's something like doesn't even have to be a bracket, just an A, then that A has got to stay there because it cannot come out of the root. If there's something that has to be added in there, no, can't do that. The moment that there's adding and subtracting, remember, roots are actually exponents, and exponent laws are only for multiplication and division. There's nothing for plus and minus. You've got to factorize if you want to do anything there. So the only time that you can actually take it out is if there is a plus and a minus, to put them in a bracket, which will not be able to come out. The 2 as well cannot come out because it's not a perfect square. The only thing that you can actually get the square root of is the x squared, which comes out, and the rest stays inside. So it's 2 in the bracket. And we're ecstatic because we got to our answer. So AB is equal to. If you couldn't get to that answer, the next part of the question was like a bonus, a giveaway, a Christmas gift. For the B part, if they say calculate AB, whether you could do it or not, you've got the formula. They gave you that AB was equal to. Then you don't do anything there, but you can get your 2 marks here for saying x is equal to
150.
2 and the bracket and the 1 and the cos 112, and you take it into your calculator and get me an answer. 1 for the substitution, 1 for the answer, 2 marks for level 0 work actually. Are you with me? Even if you do nothing there. What's the answer, please? 249 exactly. Oh yes, thank you for reminding me. So whatever the answer was, you rounded off to the nearest meter because they asked you to. Please take note of whatever the question might ask. Guys, that is now really the end of solving triangles.